Hello everyone. As part of our data analysis series of videos, in this video we will understand what is called equation of a straight line. Understanding what is called equation of a straight line is very important for us to understand the concept of linear regression. So let's get into this video and understand what is equation of straight line. As I was explaining in the introduction, equation of a straight line is a very important concept for us to understand another important concept called linear regression. So what is equation of a straight line? Equation of a straight line is a two-dimensional xy plane is commonly expressed as y is equal to mx plus c. So this is what we mean by equation of a straight line. So y equal to mx plus c, the terminologies y and x represents the variables and m represents the slope of the line. By slope of the line, what do we mean is when x changes, what will be the change in y, or what will be the rate of change of y with respect to x. That is what we mean by slope of the line. And c is the y-intercept, the point where the line crosses the y-axis when x is equal to 0. So this is how we basically get introduced to the equation y equal to mx plus c. So the reason why I use the terminology we get introduced, because very rarely we will understand what it means by reading this, but this is what the introduction is. So in this video I am trying to break this video into three parts. One, understanding what this y equal to mx plus c really means, and second part would be to explain it using an Excel. How do we understand y equal to mx plus c, Excel calculations, and the third part is to the usage of y equal to mx plus c and closed looping, how it is used in subsequent statistical analysis. So from that perspective, now we have got introduced to the equation. Let's now move on to understand this equation. So to make us understand what is y equal to mx plus c, I have taken two pairs of x and y data. So whenever we are talking about x and y data together, we call it pairs of x and y data. So here my first pair of x and y data is 3, 5, and my second pair of x and y data is 8, 8. Now what we are going to do is we are going to plot these pairs of x and y data in a simple xy 2 by 2 two-dimensional graph. So here is my x-axis and here is my y-axis. My x-axis and y-axis are intercepting each other at 0. So this is how I have created a x-axis y-axis 2 by 2 graph. Now I try to plot the first pair of data 3, 5. So I draw a perpendicular line from 3. I draw another perpendicular line from y-axis 5. So x-axis 3, y-axis 5, where these two lines intercept, I keep a dot. And I repeat the same for my second pair of 8, 8 for my x and y values. Now I got two dots got plotted. And these two dots are plotted for the values of x, 5 and x 3, 5 for x and y and 8, 8 for x and y. Now because I have two dots, now I will be able to draw a straight line connecting these two dots. And this equation for the straight line is represented as y is equal to mx plus c. This straight line is getting represented as y is equal to mx plus c. So what does this y equal to mx plus c really means, right? Okay, so let's now break this step by step. Before I break this step by step, I want to show you something which is called a fact about a straight line. When we are trying to plot a straight line with the help of x and y data points, we need to understand like how we have a Pythagoras theorem which talks about the side of adjacent side. What is the relationship between adjacent sides and the hypotenuse side? So similarly, when we are dealing with the equation of straight line, your equation of straight line should definitely cut across or pass through the intersection points of your x bar and y bar. So what do we mean by that? In this example, my x bar or x average is 5.5, right? 3 plus 8 divided by 2, 11 divided by 2, 5.5, 5 plus 8, 13, 13 divided by 2, 6.5. And where these x bar and y bar lines, when we draw a perpendicular line from x bar and y bar, where these dotted lines are intercepting, that interception point, definitely your y equal to mx plus c line should cut across or go through that particular interception point. That is a fact about this equation. Now once we understand this fact, right, now we will understand two more things, and that is when I extend this line, right, when I extend this line, right, this line intercepts my y axis and this line also intercepts my x axis. The place at which this line intercepts my y axis will be called this c value, or in other words constant. So what does c means? The value of y when my x becomes 0, or the point at which the line intercepts my y axis. So if you see this point here marked with a yellow color box, at this point the value of c, whatever be the value, I think here it will be somewhere close to 3.1 or 3.2, slightly above 3, below 4, it should be somewhere close to 3.2 or 3.1. So this 3.2 or 3.1 is nothing but if you make your x value 0, your y value will become 3.2. That is how we need to understand this intercept. Similarly, there is one more intercept where this line is intercepting your x-axis, and when this line is intercepting your x-axis, it creates an angle, and this angle will be called the slope of the line. And why do we call it slope of the line? Because m, or in other words slope of the line, is the rate of change of y when x changes. So when you put the value of m here, y is equal to mx plus c. Let's assume in this case the value of c is 3.1. Then the value of m is, let's assume, 0.5. Right? Then what will happen is if I put 1 here, my y will become 0.5 multiplied by 1 will become 0.5. This is already 3.1. My y will become 3.6. So for every unit change in my x, my y will change by 0.5 units. That is the meaning, right? That is the meaning of the value m. So here we had only two data points. So we understood how these two data points can be used to create a y equal to mx plus c equation. Now we will move on and try and understand when we have more than two data points, how this equation get created. Because when we are discussing about linear regression, we will definitely have more data points. So how the y equal to mx plus c equation get created when we are dealing with more than two data points is important. For that, I am taking you to the next pair of data, and this pair of data is x comma y, and there are four pairs of data: 3 comma 5, 8 comma 8, 5 comma 6, and 1 comma 3. So these are four pairs of data. So again, what we do, we try to plot these four pairs of data in a simple xy plot, and as we plot it, you understand that the lines are not falling on a, or the dots are not falling on a straight line, right? So as there is an increase in x, your y is also increasing, that is okay, but the lines are not falling on a straight line. So when these dots are not falling on a straight line, we will not be able to directly fit a line here. So in order to fit a line, what we are going to do is we are going to carry forward what we learned in previous slide to this slide. And what we learned in the previous slide, when we try to fit a y equal to mx plus c equation, that line should definitely cut across the x bar and y bar values. So here my x bar value is 4.25, my y bar value is 5.5. So this intersection point, my line should definitely cut across this point. So this is something that we already know from the previous slide. So let's have this understanding aside, and now we will move on to measure the value of m. So as I told already, the value of m is nothing but the rate of change of y when your x changes. So in order to measure this, in my previous videos where I was explaining covariance as well as correlation, I clearly told when you are trying to plot data in a xy coordinates in a graph and then try to draw a x bar y bar value, this part of the graph, what you see here, where you see my mouse pointer, this part of the graph by itself will be divided into four quadrants. As you see here, where you have this data will be my first quadrant, and this side will be my second quadrant, this section will be my third, and this will be my fourth quadrant. As you have more and more data point falling on this and this quadrant, you are getting a positive correlation. Why positive? X and y are increasing together. If you get more and more data points in this quadrant and this quadrant, x is increasing but y is decreasing. You can view, or you can have a look at the correlation and covariance video that I have posted before to get a clear understanding of this. I will share the link in my description. Now, in order to see how many data points are falling in this quadrant and how far is your x away compared to your y for any given pair of data, the formulas that we are going to use is the difference between individual x value to its average, the difference between individual y value to its average. So what you see here, minus 1.25 is 3 minus 4.25, and what you see here is minus 0.5 is 5 minus 5.5. We repeat this for all four pairs of data, and once we do this, we are squaring x minus x bar value. We are applying a square. Minus 1.25 is getting squared here, And similarly, we create a product of x minus x bar and y minus y bar. Both these interim steps in this formula is to understand whether the data falls in these two quadrants, and similarly whether the rate of change of x and rate of change of y, how much is both changing, are they changing in the same way, or x is changing a lot but y is changing less, or other way around. In order to find that, we are doing this interim step. And once we do this, then we are adding these values, we are creating a summation. And now the value of m is calculated by x minus x bar multiplied by y minus y bar. So summation of this divided by summation of x minus x bar the whole square. So these two individual summations, which if we divide this 18.50 with 26.75, we get 0.6916. So this will be called as m, or in other words, slope of my line. And once I know the slope, knowing c or the intercept, y-intercept becomes very easy. Why? Because the equation is y equal to mx plus c. We already know a known point for the line, because the line should definitely go through y bar and x bar. So because the line have to definitely go through y bar and x bar, I can substitute the value of y with 5.5, which is nothing but my y bar value. I can substitute the value of x with 4.25, which is nothing but my x bar value. And when I substitute these two values, and then if I solve this equation, I get my c as 2.5607. Now what is this 2.5607? This 2.5607 is my y-intercept when my x is equal to 0. So the equation will be y is equal to 0.6916, which is m value, x plus 2.5607. So where I am now plotting this 2.5607 with a yellow color box, because that will be my y-intercept. Now I know two values or 2 points for the line. So the intercept is 1 point, and the interception point of x bar and y bar will be another point. So y-intercept is 1 point, and the x bar y bar interception point will be another point. So now I will be able to fit the line which goes through these 2 points. And now this line, if you see, except for this third pair of data, this dot falling on the line, other data points do not fall exactly on the line. There is some gap between the line and the dot. This gap between the line and dot is what we call it as residual. And by residual, what we mean is it is the difference between the observed value and expected value. I will put a separate video on this. I will post a separate video on what is called residual value, what is called R square. Once I complete my video on linear regression, I will post a video on this. So at this point of time, you can understand this is the best fit line that we can plot for this given 4 pairs of data with as minimum residuals as possible, as minimum gap between observed and expected data points as possible. This is the best fit line that we can draw. So this is how we have drawn this line. Now this line will be represented with the equation of y is equal to 0.6916x plus 2.5607. So this is the explanation of the equation. Now as I told in the beginning of the video, let's move to the Excel and try and understand the data in Excel. So here I have taken the same pair of x and y data, and whatever I have calculated in PowerPoint presentation, I have calculated in Excel also. So this is where I have my m value. So this is where I have my m value. I have individually calculated. But what we can do is I can select this x and y data together. I can click on insert, and then I can click on a scatter plot. So this is my scatter plot. Those who don't understand what is a scatter plot, I will share the link of how a scatter plot get created. So this is my scatter plot. I will share the link in the description. You can go through that. For this scatter plot that I have created, if I right click on it and if I say add a trend line, and if the linear trend line is selected, and if I click on display equation on chart, so I get the equation here. So for a better understanding, let me increase the font size. Let me increase the font color so that it becomes easy for people to visualize, right? So let me increase the font size. If you see here, the exact same equation that we got. So let me copy this also, right? So if you see here, 0.6916 x plus 25607, and you get exactly the same equation here when you try to do it in the Excel. Excel is fitting this line for us, whereas we understood how this line need to be fit by a paper pencil exercise, or we solved the formula and we got this answer. So friends, I hope this video was useful for you to understand what exactly this y is equal to mx plus c equation is all about, and how this equation will help us to understand the concept called linear regression, and subsequently what is called residual squares and what is called standard error. These are the 3 videos I'm planning to upload. This will be my upcoming videos. Then it will give you a fair understanding of how linear regression need to be understood. So y equal to mx plus c equation is a very important subject before we get into linear regression. I hope this video was useful. Thanks for your time. Thanks for watching. And for videos on data analysis, Lean Six Sigma tools and techniques, Minitab tools and techniques, quality improvement videos, please subscribe and follow our channel. Thank you.